This is the ANCOVA video on the analysis plan. Analysis plan for the simple analysis of covariance is very similar to that of the two-way analysis of variance. All of its elements can be addressed visually through the scatter plot. Most of the steps of the visualization exercise have already been discussed under simple regression. The only additional step required is to verify that there is sufficient overlap in the values of the covariance. This slide illustrates what you don't want to see. All of the patients with poor functional status are seen by Facility B. Ultimately, what we'd like to do is compare facilities for patients with similar functional status. However, this will require us to extrapolate at least one of the lines beyond the body of their observed data, and that's dangerous. How much overlap you need in order to be comfortable making comparisons is something you'll have to judge on a case-by-case basis. The next step is to fit a straight line to each of the study groups and to compare the slopes of those lines. In the rehabilitation example, we fit separate lines for each type of rehabilitation facility, where these lines have pre-rehab functional status as the predictor and post-rehab functional status as the outcome. The statistical comparison uses a partial F test discussed in detail elsewhere that adds an interaction term to a reduced model that contains both main effects. If these slopes differ and interaction is present, you shouldn't fit additional models, and you should focus your reporting on each regression line separately. As with the two-way analysis of variance, for large sample sizes, your model will probably have the power to detect not only important interactions, but also those that are trivially sized. So when we say that the slopes differ, we mean that the difference is both statistically and clinically significant. Also, as with the two-way analysis of variance, if your model contains an interaction, you shouldn't look at the corresponding main effects. Here's a graphical presentation of the interaction. It highlights the fact that the impact of facility depends upon initial functional status. This slide contains some text fragments for reporting an interaction. You might say that in Facility A there's a strong relationship between functional status pre- and post-rehab. To predict the post-rehab status, take the pre-status, multiply by 1.5, and add 10. In Facility B, the relationship is less strong. There, your prediction would start by pre-status, multiply by 1, and add 30. The slopes are statistically different, as illustrated by a p-value of 0.01 for testing the model's interaction term. These differences in slope are also of a clinically important magnitude. Plugging 40 into both equations, we see that identical results are expected for patients with pre-rehab functional status of 40. Facility A has better outcomes in general for higher functioning patients, defined as functional status above 40, whereas Facility B is associated with better outcomes for lower functioning patients. On the other hand, if the slopes of the two lines are similar, equivalently, if there's no significant interaction in the ANCOVA model, you should refit a model with main effects only. One advantage of such a model is that the impact of the predictors can be reported separately. As should be apparent, the impact of facility is the same regardless of initial functional status. Within the main effects model, use partial F tests to assess the impact of each factor after accounting for the impact of the other. Here's a graphical presentation of the main effects. Should be apparent, the impact of facility is the same regardless of initial functional status. The regression coefficient for facility is the vertical distance between the two lines. This slide contains some text fragments for reporting main effects. The regression-like model coefficient says that, regardless of facility, when comparing two patients with a 1-unit difference in pre-rehab functional status, the patient with higher pre-rehab status is expected to have 1 unit higher post-rehabilitation functional status as well. The ANCOVA-like model coefficient, and the primary point of emphasis in the reporting, says that after accounting for differences in case mix, outcomes in Facility A are 10 units better than those in Facility B. The confidence interval ranges from 8 to 12, and all values within this interval are clinically significant. Both main effects are statistically significant, with p less than 0.01.